From Baker, the course team leader for applied science, and if you are thinking of coming to Long Road to study applied science, we have a little summer series of tasks for you to do. So my job today is to guide you through the tasks and explain probably how you need to present your work when you arrive in September. So if I share the actual summer work with you, and I'll guide you through step by step. Okay, it begins with a biology task. So one of the key skills is to be able to label an animal and a plant cell. So you have a series of organelles that you need to add to two diagrams. There is your plant cell diagram. If I keep on scrolling. There is your animal cell. What you can do, you can obviously copy those images, you can stretch them, you can put them into a PowerPoint, you can add the labels digitally. If you do have access to a printer, then obviously you could just print the homework off and add labels by hand. Okay. Go to the next activity. Okay, so here we have an electron micrograph. So you've got a couple of questions to do with magnification. So again, that's going to be using some of your maths that you've learned at GCSE level. And then we've got a very, very short biology research task where we just want you to look up type 1 and type 2 diabetes. So what will cause type 1 and type 2? They both differ. And also, how do the treatments of both of those two diseases, what have they got in common, and what's different about them? Okay, next activity is chemistry based. Okay, so you've got yourself a question there. So chemical reaction, and this needs to be attempted step by step. Every question relies on some previous information from the question just before it. So your first job is just to balance the equation. I've left some spaces there with underscores, so you'll need to work out what those numbers are to balance that equation. Then you need to calculate the relative formula mass for every single one of those substances. You've got 5 substances, so you need to work out 5 relative formula masses. Then you've got a mole question. Okay, so I just want to know what is the number of moles of potassium carbonate in that question. Therefore, you will need to use the balanced equation to work out how many moles of hydrochloric acid are going to be required to neutralize the carbonate. From there, you can work out how much potassium chloride is formed, because that's one of the products. Then it finishes by stating how much, in terms of centimeters cubed or decimeters cubed on its both units, how much carbon dioxide gas would be collected in a measuring cylinder. Just gone too quickly for that one. Next one, you've got lots of space here. Can you draw an atom as you currently understand it and add the labels of any subatomic particles, where you would find those subatomic particles and their charges and masses relative to each other? Okay, next is a periodic table question. I'm having trouble keeping it in place actually. So in your own words, can you describe the arrangement of the elements in the periodic table? The periodic table is a wonderful body of work, and it's got many patterns and trends to it. So if you can draw out your knowledge of GCSE chemistry and just basically explain in the space below how the periodic table is arranged. It's arranged in 3 unique ways. So let's see if you can remember those ways. We've got a little physics task for you. Okay, this sometimes is thought of as chemistry, but it is in fact physics because it's particle theory. So you've got boxes. I'd like you to draw the arrangement of solids, liquids, and gases in those boxes. We've also got arrows, so you could add names. So what's the name given to when a solid turns into a liquid, for example? You've got arrows going backwards, so what's the name given when a gas turns back into a liquid? And you also add some notes to describe their movement. Okay, one of them has no movement. I'm not going to give you a clue. It does have something. Okay, the others have movement, and they are relative to each other. So again, just some really good notes. It can be bullet points for this activity. The next one is you've got some data, and I'd like you to interpret the data a little bit. Okay, so you need to plot a graph of time versus temperature. I've included a little small bit of graph paper there for you if you're going to print this out. If you want to use Excel and you're quite proficient with the use of Excel, you can cut my table in and you can use the graph functionality to produce your own graph. I'm quite happy for you to do that. Just make sure you add the relevant labels. Make sure, if you're doing it by hand, that your scale is linear, okay, meaning your numbers go up nice and evenly. So that's your little physics graph related task. We've got a wave diagram that needs labeling. So I'd like the frequency, wavelength and amplitude noted for that wave. Then a little activity on electromagnetic spectrum. Okay, so can you remember the types of electromagnetic waves? Start off with those waves that are the highest wavelength or the lowest frequency, okay, which is on the left hand side. Then we've got a bit of lab skills questions. Okay, can you basically name those two pieces of glassware? The results table in there is some volumetric measurements, so it could be from a titration, for example, where piece of equipment A has been used and 3 measurements have been taken. Okay, equipment B has been used 5 times, and that's all of the 5 measurements for equipment piece of B. So your job by looking at that data is which is the most precise and accurate, and which one was the most reliable. Something new for this year is a different style of activity, which will take you a bit of an open-ended task in places, and you can go as deep as you want with your research on this. But essentially, I'll read straight through this, I'll let you read this in your own time. We'd like you to find out about genetic engineering. So any stories, any developments that you can find about genetic engineering, please pop into that first table. Stop. Task 2 wants you to read an article from the BBC News Archive. So it was a January 2019 article. Okay, plenty of scientific reading there for you to do. Okay, plenty of science to read about and people to read about within the article. And we want you to do a couple of tasks based on that. So from the article, can you consider what are the economic benefits or downsides of using chickens for medicine? What would be any environmental issues? Are there any ethical issues? So I can imagine people will have ethical issues about using chickens in this way. And what might be the social impacts? So is it that new jobs might be created from this kind of industry? And I'd like you to consider, whoops, I'm probably going a little bit too quick, the people or organisations within the article and what influence they have. So are they somebody who will have a bias towards a particular slant of the article, or will they be very, very neutral in the way that they come across? So that's your job to find out what their influence is. Next one is to come up with what areas for future development or further research is needed to back up this article. And then the last one, I'd like you to think of yourself as a journalist for your secondary school and imagine that they have a newsletter. I'd like you to basically write an article describing the advantages and disadvantages of genetically modified chickens for medicine. So think about who would read the actual newsletter within your school. Think about what you want them to learn. Okay, so make sure you introduce genetic engineering and also put in your point of view. So it's quite important as a writer that you kind of express your thoughts on the actual issue. So that sums up the homework. It should take you probably anywhere between 6 to 10 hours, I would imagine. Okay, best of luck doing it, and please have it ready for your teachers in September.